Hello everyone, welcome to my YouTube channel Decoders Team. So today we are going to see a binary number system related some theorems. Okay, what is binary number system? As we have seen in our last video as well, binary number system is nothing but which is having the base as 2. Base is going to be 2. Okay, so what is the minimum value of it? It is going to be minimum value is going to be 0 and the maximum value is going to be n minus 1, where n represent your base, that means 2 minus 1. If you do this calculation, it will give 1. So this is the maximum value that we are going to represent a digit in binary number system. Okay, so as we are known, our computers are like they are going to understand language in terms of zeros and ones. So there we are going to use this binary number system while converting our whatever we are human language is going to be converted into ones and zeros, and that is going to be interpreted by the our computers, and by that, on the basis of that, the computer is going to perform some multiple tasks. Okay, so we'll see some theorems which are related to the binary number system. So there are some gates like OR gate and gate. So first we are going to take at OR gate. So Boolean theorems related to its number system. Okay, first one related to our OR gate, related to OR operation or gate. So these are mostly important theorems that you should remember in solving the circuit's equation. So first one says that a plus 0 is going to be a, where a is nothing but a variable. It's kind of variable. It is going to take possible value as 0 or 1. Okay, a plus 0 is going to be a. We'll see one by one the theorems related to OR gate, but let's mention those ones. Next, a plus a is going to be a. Okay, next one, a plus 1 is going to be 1. Next one, a plus a bar is going to be 0. 1. Okay, these are the theorems related to our OR gate. We'll see one by one how the theorems can be used. Suppose first one says a plus 0 is going to be a. Okay, so take a as the first one, a as 0. If you put a equal to 0 in this equation, 0 plus 0 is going to be 0, right? 0 plus 0 is going to be 0. 0 is nothing but our a value, which we have considered at prior only. Next, take a equal to 1. If you take a equal to 1, 1 plus 0 is going to be 1. Okay, so this is going to be a value, which we have considered at this state. Okay, so here we can see if you add 0 in a variable, the same variable we are going to get at the result at our final output. Okay, next comes a plus a is going to be a. So see over here, a plus a means same variable where when we are going to take OR of it with itself, then the result whatever we are going to get is nothing but the same variable. Okay, so suppose a equal to 0. 0 plus 0 is going to be 0. We are calling it as plus, but the in between this OR operation is going to be happen. Okay, next one, a equal to 1. 1 plus 1 is going to be 1. So you can see over here, when we consider a as 0, ultimately we got at 0. When a equal to 1, same number we got at output. Okay, next comes a plus 1 equal to 1. A plus 1 equal to 1. So this is the most important theorem related to OR gate. So what it says, 1 plus anything, the result is going to be 1. We don't care about what is there written in anything, the position of anything. Okay, so like that, the equation can be resolved as a plus 1 means 1 plus anything is going to be 1. Ultimately we are going to get result as 1. So we'll see how this can be written. I'm going to put a line in between. So see over here, 1 plus, suppose there are multiple variables like a, b, c. These three variables we are going to consider, and by this we are going to take one dummy example of it. 1 plus ab plus bc plus ac. So whatever the equation we have written over here, the ultimate result of is going to be 1. It don't care about what are the values that the equation is going to get in this remaining. This term, this whole term is represent our anything, 1 plus anything, right? Anything. I mean, the whatever weight of this whole thing is don't care, I mean neglected by the once we add 1 into it. So the result of is going to be 1. So this is the most important property that we are going to use in resolving problem in our future video. Okay. So next is our a plus a bar. A bar is nothing but the complement of the number which we have taken at the position of a. So next comes here, a plus a bar is going to be 1. Okay. So we'll see this property. Suppose a equal to 0, then a bar is going to be 1. The complement of a, the complement of 0 is going to be 1. Suppose a equal to 1, then the complement of the number whatever we have taken over here, the complement is going to be 0. So let's add a plus a bar first, for first. Okay, for first iteration we are going to see a plus a bar. A is 0, 0 plus a bar is 1, 0 plus 1 is going to be 1. Okay, ultimately we got 1. Suppose for second iteration, 1 plus 0 is going to be 1. So you can see over here, when we add the complement of a variable with itself, we are going to get result as 1. Okay, hope this is clear to you all. So we'll see some properties related to our AND gate. Okay, related to our AND gate. So second, related to AND gate or AND operation, you can say. Okay, the first property is like a dot 0 is going to give you 0. This dot is represent the AND operation between two variables. Okay, next a dot 1 is going to be a. Next comes here a dot a is going to be a. Next one, a dot a bar is going to be 0. Okay, we'll see one by one what are these properties said. Okay, the first one is like a dot 0. A dot 0 is going to be 0. So what this property says, if you take AND operation of any variable with 0, the ultimate result we are going to get is 0. Okay, so if you see a equal to 0, so 0 dot 0 is going to be 0. Okay, next take a equal to 1, 1 dot 0 is going to be 0. Okay, this is what this property says. Next comes property as a dot 1 equal to a. Okay, so we'll see what actually this property is. Once we take the dot operation of any variable with 1, the ultimate answer we are going to get as the same variable. Okay, so if a equal to 0, then 0.1 is equal to 0. So you can see over whatever the value we had considered as a, the ultimate result also similar to a, right? Same as a. Next, a equal to 1, 1.1 is going to be 1. So you can see the values of a and result whatever we got are same. So this is all about this property. Next, third property is like, we'll use other pen. A dot a is going to be a. So see here, once when we take AND operation between the same variables for multiple times, then the ultimate result we are going to get as the same variable. Okay, if you write this as a dot a dot a for n number of times, if you write a dot a dot a dot a dot like n number of times, the whatever result we are going to get as a only. So if you take example as a equal to 0, a equal to 0. If you take 0.0 for multiple times, it is going to give you as 0 as the result. Okay. If you take a equal to 1, 1.1 is going to be 1. So ultimately you can see the result whatever you got here over here, thus it is same as the value we have considered as a. Next is a dot a bar. Okay. Next one is a dot a bar is going to be 0. So a bar is nothing but complement of the number. Okay. Suppose a equal to 0, the a bar is going to be 1. When we take AND operation in between these variables, so 0.1 is going to be 0. Okay. Hope this is clear to you all. Next, take a as 1, the a bar value is going to be 0. So 1.0 is going to be 0. Okay. So these are the some properties related to the our AND operation, and these are the most important properties that we are going to use in our further videos as well to solving the problems related to Boolean algebra. So we'll see how a dot operation is going to be distributed over OR operation and how OR operation is going to be distributed over dot operation. So next topic is like how, this is most important, how dot operation is going to be distributed over a OR operation, you can say plus operation. So we'll take some dummy example of it. Suppose a plus b, a dot b plus c. This is an example. So how this dot is going to be distributed over this OR operation? We'll see. So this is going to be like a dot b. First, the dot operation given to the first variable in the bracket, which is present over here as b. A dot b plus should come in between a dot c. Okay, a dot c. So this is how we can write this equation. Okay. Next comes how the plus operation is going to distribute it over AND operation. How plus distributed over dot. Okay. Take example as same example, a plus b dot c. You can see we have written dot in bracket and plus outside the bracket. So how this plus is going to be distributed over this means how the a variable is going to be written along with each variable that is contained in this bracket. This is going to be like a plus b. In between this dot should come dot a plus c. This is how it is going to be distributed. Hope this is clear to you all. In this bracket, there may be multiple variables that can be written, and the same way the distribution has to be happened. Let's take one example of it. Okay, suppose a plus a dot a plus b dot c dot d dot e, like that. Many variables are there. So how this can be written? A plus b dot a plus c dot a plus d dot a plus e. Okay, this is how this is going to be written. Hope this is clear to you all. If you are having any query related to this concept, you can post it into the comment section. We will happy to help you out. Thank you so much for watching.